Hey yo, what is up guys, Akash here back with another video. So recently I was working with the project with the Arduino and I needed a transistor circuit over there. So I went for the popular BC547, which is our NPN transistor over here, but this little baby packed a little bit of less power than it was required. So I searched online and found the big daddy of the transistor, basically a heavier version of the BC547, which is the BD139. So BD139 is a power transistor, and today we'll be looking at the power transistor pair that we can say, which is the BD140 and the BD139. So BD139 is a NPN transistor, whereas the BD140 is a PNP transistor. So these are the power transistor pairs that we'll be looking at. We'll be covering a basic theory of how transistors work in general and what is the advantage of BD139 or the BD140, and how can we use it with our projects on the Arduino or an ESP8266. So if you're interested in something like that, stay tuned to the video. I have got many PCBs manufactured from PCBWay.com. They are the leading PCB manufacturers from China. They offer 10 PCBs for $5 only. They offer fast turnaround times as fast as 24 hours. Apart from getting PCB manufactured, you can get your PCBs assembled from them for just $30. Do check them out for your PCB related needs. They always have some offer or competition running on their website. Their link will be in the description box below. So firstly, talking about the physical overview, we do see a hole in the transistor, and that is because of mounting it to a heatsink. Because they are a power transistor, they have the ability to emit a lot of power and dissipate in the form of heat. So that is why you will require generally a heatsink mounted to this when you use it in high power applications. Apart from that, like the classic BC547 or any other transistor, both of them have 3 terminals, and just let's quickly look at what the terminals are. So the pin configuration of all the BD series transistors, be it BD139, BD140, 136 or 135, all have the same pin out. The first pin from the left is the emitter pin, then we have in the middle the collector pin, and towards the right we have the base pin. Whereas when you draw circuit diagrams or you try to recreate circuits, this is not the figure that you will be seeing, and you will be seeing this type of diagram. So this is a schematic of the transistor, you may say. This also has 3 pins, namely B, C and E, which is base, collector and emitter. In the transistor, generally B, C and E are not marked. You need to identify the base, which is attached to the longer dash, the collector, which is an ideal pin, and the emitter has an arrow in it. The arrow, when the arrow comes out of the base side, that transistor is an NPN transistor. So we have this schematic of the BD139 because the BD139 is a NPN transistor, whereas the BD140 is a PNP transistor. So if we would have taken a look at the BD140 schematic diagram, the arrow would have been going inside into the base, because that is how the emitter of a PNP transistor works. The arrow actually represents the direction of the current flow of the transistor. In an NPN transistor, the current will flow out from the emitter, will come in through the collector and through the base. We will be looking more about this in the video. So transistors are present pretty much everywhere in all the circuits that you can imagine, because they are like the basic building blocks of analog electronics. And there are many applications, but we'll be looking at major 2 very popular applications, which is transistor as a switch and transistor as an amplifier. So we'll be seeing the basic diagrams for this. So let's start with transistor as a switch. This is the diagram of a classic transistor as a switch. Here we have again used the BD139, which is the NPN transistor. We have the arrow of the emitter coming outside from here. So what basically happens here is, when a small voltage is applied to the base terminal, which is this one, we can label it as input, there will be a switch on at the output. So if we have a load over here, maybe a bulb, maybe a motor, and anything else like that. Then when there's a small voltage applied at the input at this terminal, we will see a large output at this terminal. One of the classic examples and day-to-day usage of this circuit is a transistor as a switch circuit in a relay, wherein when we apply a small voltage at the input of the transistor, which is basically the base, there's a switch opening by the transistor which basically starts the current flow from this branch and which operates the relay. So how this runs is, when a small voltage is applied on the base terminal, then a small base current flows which induces current in the collector branch. So basically when there's a small current flowing through here, this switches on the transistor and there starts to flow a current from here like this. So we can safely say that if we provide an input at the base of the transistor, then the transistor will switch on. So this is how a transistor as a switch works. There are many applications. You'll find the list of applications and many other circuits on my instructables page. The link will be in the description box below. Do check that out for a more detailed version. Now moving on to the amplifier part. So this is basically a common emitter amplifier. We also say this as a CE amplifier. Again, for this example, I've used the BD139, which is the NPN transistor. What happens here is basically there's a small voltage applied on both the sides. We basically call this as biasing in complex terms, if you can say. So we bias this side of the circuit with some voltage and we bias this side of the circuit with some voltage. But not getting into too much technicalities, we can just simply understand by an amplifier that when a small voltage is applied or a small signal is amplified to a higher volume or decibel level, you can say, to give the output. And that is how an amplifier works. In an audio amplifier, you apply a small signal, a small sound, and that gets amplified to a higher volume. That is what this amplifier also does. So if in the input there's a small signal, AC signal, that is provided, the amplifier will amplify that in amplitude and will provide a higher amplitude signal. So the voltage peaks will be higher over here, and that is how a NPN transistor or a PNP transistor works as an amplifier, and this is the basic circuit of it. The main equation that runs both of these and many other circuits in the transistor is this, which says that the current of the emitter is equal to the current of the collector and the current of the base. So the net current flowing out of the emitter will be equal to the collector current plus the base current. So the current flowing in this terminal and this terminal, when we sum those currents up, will be equal to the emitter current. And this is a very important equation if you want to design complex circuits using transistors. Apart from that, talking of current, and the entire idea of the transistor is that the transistor is a current controlled device. So we have something similar to a transistor, which is a MOSFET. A MOSFET amplifies voltages and it is a voltage control device, whereas the transistor is a current control device. And whenever you see any graphs or transfer characteristics of a transistor, maybe BD139 or BD140 as well, you will see that all of them include mostly current inputs and current outputs. Because the transistor is not voltage driven, it is current driven, as we see with this equation as well. More the current in the base terminal, more will be the enhanced output in the collector terminal, and this is basically the current charts that we just saw. Now that we have a detailed insight about transistors, their applications, the pinout, let's come back to the point where why is this beefy transistor, which is probably more expensive than the BC547, advantageous, and why was I looking at this transistor in the first case. So these, as I said, are power transistors. By power I mean when current is flowing through these transistors, there's some power dissipated as heat at the collector junction, you may say, because there's a lot of current flowing through the collector and the emitter, so there's a lot of heat generated when the current is higher. Talking about current, the maximum current that these beefy boys can handle at the collector is 1.5 amps. Yes, that might not seem too much, but when we compare it with the BC547, the BC547 can only handle 0.1 amps. So there we go, directly we can see the 15 times jump in the current that these big transistors can handle. So when you have power circuits wherein there's a lot of power involved, a lot of current needs to be flowed in. So when we have high power amplifiers, we might not see small transistors like BC547s. In high power amplifiers, we'll see beefy transistors like the BD139s and even more powerful transistors that might handle like 15 amps. Talking about power that this transistor can dissipate at the collector junction is 12.5 watts, whereas the BC547 can only dissipate a max of 0.5 watts. So there you go, directly you can see the power dissipation ability of the bigger transistor as well, and that really gets us the application of this beefy transistor over the BC547 or the BC557. Another point before wrapping up is that as we have this pair of the NPN and the PNP transistor, we also have a BD135 and 136 pair, which is similar to the BD139 and the BD140. The BD135 is an NPN transistor and the BD136 is a PNP transistor. They have similar specs, so if you're not able to get your hands on the 139 and the 140 for your circuits, you can look at the BD135 and the 136 as well. But generally BD139 140 pair is more popular, so you can go ahead for this one. So I hope this tutorial was helpful for you guys. You can head over to the links in the description for more details on this, and this is it from my side for today. Thanks for watching. Subscribe to our channel if you haven't till now. Also hit the bell icon to stay notified. This is Akash signing off.